Earlier, we talked about operations that can be performed on whole numbers, like addition, subtraction, multiplication, and division. In this video, we're going to be going over the order of operations, which happens when you have problems that combine multiple operations in one. For example, you might have a question that combines an addition step, a subtraction step, and then a multiplication step. Or you might have another question that combines a division step and a multiplication step. So let's talk about what we would do in this situation, and we'll see why it's so important. Let's go over the situation where I have 3 plus 4 times 2. So this is my example for now. Now, you might just think at first glance, let me just go for it step by step, working left to right. So I start off with 3 plus 4. I know that's a 7, and then I multiply it to a 2, which gives me 14. If you did this, you'd be completely wrong. And let me explain why. In fact, when we are working with multiple operations as part of one problem, there's a strict code of conduct you need to follow. And that code of conduct is called PEMDAS. P-E-M-D-A-S. Please excuse my dear Aunt Sally. Or, in math terms, parentheses, exponents, and you probably already guessed it, but multiplication, division, addition, and subtraction. Now, what PEMDAS teaches us is that if we are in a situation where we have many of these things going on in one problem, we're going to go through them one by one. So we're going to do it step by step. So in this problem, I'm going to rewrite it here. We have 3 plus 4 times 2. We're going to look at PEMDAS and see which letter comes first for our operation. So we can see that M for multiplication comes before addition, right? So that would tell us that we need to do the multiplication part first. So over here, 4 times 2, 8. Then I would add the 3, and I would get an 11. This here would be the correct answer for this problem. Now, over here, you might be noticing there's also parentheses and exponents. So let's see what happens. Let's take a look at the same problem here. 3 plus 4 times 2. But notice that I add these little curves around my 3 and 4. These curves are called parentheses. You're probably familiar with them. But what this means is that now you might already be thinking, okay, I know I need to multiply first because multiplication comes before addition. But now in this situation, having the parentheses changes things up because P is the first letter in PEMDAS. That tells us that is first in the order of operations. Out of all these operations, that is in the first position. So we need to start with whatever's in the parentheses. So even though inside the parentheses we have addition, which comes after multiplication, we ignore that. We just say, hey, parentheses comes first. So now we would actually add first because in the parentheses we have addition. So we get 7 in the parentheses, and then we have times 2, 14. In this scenario, 14 would be correct because we started off with the parentheses. So we've gotten parentheses down. Let's talk about the next letter, exponents, or E for exponents. Now, you may or may not be familiar with exponents already, and I'm going to give you a brief overview either way. So in many times in math, you're going to be multiplying the same number over and over again. So let's say we have this expression here. 3 times 3 times 3 times 3 times 3. So I have 1, 2, 3, 4, 5. I have 5 3s here. Now, somebody decided that, hey, if we had a situation when we have the same number being multiplied, there should be an easier way to write this because imagine I'm multiplying 100 3s to themselves. Would it be fair for me to be writing out 3 times 3 times 3 times 3 times 3 until I reach 100 3s? No. The faster way would be to come up with this guy called exponents. Over here, we have 5 3s. So instead of writing it like this, we would write the number 3, which is a number we're constantly multiplying to itself, and we would write the amount of 3s, meaning the amount of times I have to multiply it to itself, up top like this. This would tell me 3 to the 5th power. And I know this is kind of a wordy way to say it, but all it means is that these powers, which is the same thing as exponents, tell you how many times you need to multiply that number to itself. So let's start smaller. Let's say we have 4 times 4. You know that's 16, right? But in reality, we would just write 4 to the power of 2. There's 2 4s. That tells me, okay, I need to multiply 4 times 4, meaning I need to multiply 1 4 to another 4, so 2 4s in total, and that gives me 16. And that would be 4 to the 2nd power. What if I added, well, not add technically, but what if I decide I want to multiply another 4 to this? So then that becomes 4 to the power of 3, because now I have 3 4s. That would be 4 to the 3rd power. And you kind of get the gist already, but let's do one more. Now I've decided I need another 4. So it's 4 to the 4th power. So it's 4 to the 4th power. And it goes on and on and on, meaning however many 4s you have that you're multiplying to each other, you're going to write that as an exponent, and you're going to write that up top of the number that you are multiplying. Now, for these situations where we have, say for instance, the 2nd power in particular, or the 3rd power, people realize, meaning mathematicians realize, that we do this so often, we can give some of these their own names. So this is called a square, and this is called a cube. And we'll talk a little bit more about this as time progresses, what this actually means. But that's why instead of saying 4 to the 2nd power, you can just say, oh, this is 4 squared. You would add a d at the end. Or for 4 to the 3rd power, you would say that's 4 cubed. So the same thing applies. If I say 5 times 5, I would say, oh, that's 5 squared. Or if I would say 6 times 6 times 6, I can say that's 6 cubed. So instead of saying 6 to the 3rd power, I'm saying 6 cubed. Instead of saying 5 to the 2nd power, I'm saying 5 squared. All this just to give you a little refresher or reminder on exponents. So the point being, if I have an expression now where it's like 5 squared plus 5. In this situation, if I'm looking at PEMDAS, if I'm looking at the order of operations, I realize that, hey, wait, this little number up top is an exponent. It means that 5 is being squared. It's 5 squared or it's 5 to the 2nd power. I need to do that first before adding. Because if I were to add 5 plus 5 and then do it, the answer would not be the same. So I do 5 squared first. So that just means 5 times 5, right, plus 5. So 5 times 5 is 25 plus 5, and that is 30. That would give me my final answer. So that's what that part means. Now the rest, you're already familiar with multiplication, division, addition, subtraction. So really, if any of these came, it's just a matter of following the order of operations. Now, you might remember from our previous conversation that multiplication and division are inverse operations of each other, and addition and subtraction are inverse operations of each other. What this means is that if I have an expression over here, so let me just kind of give myself some U space. If I have 3 plus 7 minus 4, it wouldn't actually matter for me to do addition first instead of subtraction first, even though A comes before S. But because they're inverse operations, I could technically even do subtraction first. 7 minus 4 is 3, plus 3 equals 6. And if I did it with addition first, I would get 10 minus 4 is 6. Both of these are the same. So the order doesn't matter when it's inverse operations. And the same can be demonstrated with multiplication and division. So I have 3 times 4 divided by 2. So let's do 4 divided by 2 first. We get 2 times 3, which is 6. And then in this case, if we did multiplication first, we would get 12 divided by 2, which is also 6. Both of them being the same, meaning that if multiplication and division come together in an operation, it won't matter whichever one you do first because of the fact that they're inverse operations. That being said, though, if multiplication and addition came together, then multiplication would have to go first because multiplication and addition are not inverse operations. Same thing applies. If division comes before subtraction, division must be done before subtraction because these are not inverse operations. So that whole idea of doing whichever one doesn't apply unless those two operations are inverse operations. Hopefully that makes sense. And will you please excuse my dear Aunt Sally?